Question 11 is coming from circles. The diagram shows the circle with equation, this one here. Parallel tangents, each with gradient 1, touch the circle at points A and B. Part A, find the equation of the line AB, giving the answer in the form y is equal to mx plus c. Now for these parallel tangents, in fact, let me write the statement. For two parallel tangents, for these two parallel tangents touching the circle at points A and B, the line AB must pass through the center of the circle. So this means that AB is the diameter. So AB is a diameter. Why is it like this? So if I connect these 2 points here, A and B, okay, we know that from circle theorems, the tangent is always perpendicular to the radius or diameter, okay? They are perpendicular. So you see that. And the center is here. From here, we can see that it has to be 4 and then -1, okay? So that is that. Now, we are going to have perpendicular lines. Remember, the gradient of this one is a 1. So for perpendicular lines, we know that m1 times m2 is equal to -1. Okay? For perpendicular lines, m1 times m2 is equal to -1. That means m2, which is going to be the gradient of AB, is going to be -1 over the gradient of this one, which is 1. So meaning we are having -1. You see that? Okay. Now, when you are finding the equation of a straight line, you should get its gradient and at least one point through which it passes. So when we have y, y minus y1 is equal to m into x minus x1, this line here passes through the center of the circle because the diameter passes through the center of the circle, right? And the center is for -1. So we shall have y, then minus 1, that will be a +1, which is equal to, this one is a -1, and then x minus, this is 4. So when I open the brackets, here we shall have the positive now becoming a negative, the negative now becomes a positive. And then when 1 crosses the equal signs, we shall get it as -1. That means the equation of the line AB is going to be -x, then +3, as simple as that. Part B, find the coordinates of A, giving each coordinate in the third form. Of course, at A, we are seeing the tangent, or we are seeing that line AB meeting the circle. So if we have the equation of this line and we also have the equation of the circle, that means we can solve them simultaneously. Okay, so we are going to say that solving y, which is equal to -x plus 3, and the equation of the circle, which is x minus 4 squared, then plus y, I think it's a +1, yes, squared, which is equal to 40, simultaneously. Okay, simultaneously. Now, that means this y, I will put it in the place of this. So this 3 will add to this 1, then I will get a 4, not so? So this, therefore, implies that we have x minus 4 squared, then plus, this will be minus x, then what do we have here? Plus 4 squared is equal to 0. You can expand this and then you solve that quadratic, okay? But I can simply make this one resemble, I can say, pull out a negative here. If I pull out a negative here, then that means here I will have x, then minus 4, okay? Then squared. You see that? Such that I have this one common. Now, when we square, of course, the negative will disappear. So we shall have x minus 4 also here. You see that? Now this is twice of it. So 2 of x minus 4 squared is equal to 40. Divide all through by 2. I'm making x the subject. So that will be 20. Then take the square root. So x minus 4 will be plus or minus the square root of what? 20. But the square root of 20 is the same as saying square root of 4 times the square root of 5, right? And then this one gives us a 2. So that means x here is going to be, when this one crosses, it becomes a plus, right? So positive 4, then plus or minus 2 root of 5, okay? Because this one is 2 root of 5. Now, when we go back and we check here, the x-coordinate is a negative. You see this? The x-coordinate is a negative. So, from these two values here that we are having, we are going to choose one. Of course, 4 plus 2 root of 5 cannot be a negative. This one is going to be a positive. So, that therefore implies that for A, then the x-coordinate is equal to 4 minus 2 root of 5, okay? Let's check it out and see whether it is really a negative. 4 minus 2 root of 5. It's a negative, you see? It's a negative. Then how about now the y-coordinate? Because they said coordinates. So we need the x-coordinate and then the y-coordinate. So I can substitute here. We shall have negative. The x-coordinate is 4 minus 2 root of 5. And then we add a 3. So we shall have negative 4 plus 3. That will be a negative 1, not so? And then negative makes this one a positive. So plus 2 root of 5. So smartly, I can write the coordinates of A as A 4 minus 2 root of 5 in the third form. And then also this one is negative 1 plus 2 root of 5. As simple as that. Part C, find the equation of the tangent at A, giving the answer in this format. Of course, you know that the gradient is 1. So y minus y1, which is equal to m into x minus x1. Now we are going to have our coordinates of A here, 4 minus 2 root of 5, then negative 1 plus 2 root of 5. Remember, if a point lies on the given curve, then its coordinates must satisfy the equation of that line or the curve, okay? So the y-coordinate, we have y here, then minus y1 is going to be this negative 1, then plus 2 root of 5, and then we go this side, m, the gradient is 1, then x minus x1 is this one here, so which is 4, then minus 2 root of 5, like that. So meaning y is going to be equal to, open the brackets here, so it just, we get x here, then minus 4, then plus 2 root of 5. Now this one here, when it crosses, it becomes a positive, so already this one is a negative, so it remains as it is, okay? I'll just say minus 1, then plus 2 root of 5. Now this one is going to be simplified. We first take away this one here. So we shall have minus 1, then plus 2 root of 5. Then our y is going to be equal to x. Then minus 4 minus 1, that one gives us negative 5. And then 2 root 5 plus 2 root 5, that one becomes 4 root of 5. And that becomes our answer. They said where C is in the third form. This is the C you're seeing here, the whole of this, okay? So that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.